What's the phase constant for the harmonic oscillator with the velocity function v of t given in figure 15.32 if the position function x at t has the form x equals xm, the amplitude, times the cosine of omega t plus phi, and the vertical axis scale is set by Vs equals 4.0 centimeters, and Vs is right where it crosses the axis. So, because this is velocity as a function of time graph, and we're given the formula for a position as a function of time, we know that the velocity is the derivative of position. So, we can do v at t is equal to negative omega xm times the sine of omega t plus phi. So the derivative of cos is negative sine, and you just bring out the omega. So then we also have to know that the amplitude of the velocity is equal to omega xm, which is right here. And we know, based on this graph, that the amplitude of the velocity is equal to 0.05 meters per second. And how I got this is we know that each line is an extra centimeter per second, so the amplitude of the velocity is 5 centimeters per second, or 0.05 meters per second. So then we know that when t is equal to 0, that the position, or the velocity, is equal to 0.04 meters per second. So now we have a Vm value and a V value that we can sub into this equation to solve for phi. So we have 0.04 is equal to negative 0.05 times the sine of omega, the angular velocity, times 0, because the time is 0, plus phi. And then we can just solve for phi. So phi is equal to sine negative 1 of 0.04 divided by negative 0.05. And this gives us negative 53.13 degrees, or negative 0.9223 radians. And because this is a negative value right here, it must have been a shift to the right. A translation to the right has a negative phase constant value.